Diffraction is the phenomenon of bending of light when it comes across obstacles or apertures whose size is equal to that of incident source wavelength. There are two types of diffractions, Fresnel diffraction and Fraunhofer diffraction. So in this video, we will see Fraunhofer diffraction due to single slit. First of all, let us consider source. Light from the source is emanating in all possible directions. Okay, it is moving like a spherical wavelet W dash. Now we are going to keep a double convex lens. This double convex lens is going to make them into parallel beam of light, a collimated line. Now wavelet W dash changed into a plane wave. Let us consider a slit of width E. Let us name this as AP. AP is the slit whose width is equivalent to E. Now light beam W dash reached this slit of width W dash reached this slit of width E. According to Huygens Fresnel, every point on this wavelet acts like a secondary source and radiating light in all possible directions. Let us consider two particular directions in this case. First of all, those rays which are making theta is equal to 0 degrees. So this is the incident ray, this is the diffracted ray, they are parallel to each other, theta is equal to 0 degrees. Again, let us keep another plano. Is it plano? No, double convex lens. Right? After passing through this lens, the light is captured on a screen. So the light beams which are moving in theta is equal to 0 direction converges at a point P. Now if you see this picture, the distance AP and BP are equal. That means the two rays are traveling same path difference. So that's why the point P becomes central. So it is satisfying the constructive superposition condition, and we will get a central maxima in this case. Now let us consider another ray which is moving in a different direction. See, we are looking other rays which are making an angle theta not equivalent to 0. They are converging at a new point P dash. Now we can understand from this picture is the distance AP dash and BP dash are not same. BP dash traveled an extra distance compared to AP dash. So let us try to find out the path difference in this case. So path difference in this case can be obtained by drawing a perpendicular line from point A. So let us assume this as C. So in this case, BC is the path difference. Okay, BC is the path difference. So what is the value of BC? So from this, sine theta is equivalent to BC by AB. But what is the width of AB? That is E. So the difference path difference BC is equivalent to AB into sin theta, or else E sin theta. We are replacing AB with so in this case path difference is equivalent to E sin theta. The corresponding phase difference corresponding phase difference is equivalent to 2 pi by lambda into path difference. So the path difference in this case is 2 by lambda into E sin theta. So we have calculated the path difference and corresponding phase difference in this case. Let us consider this slit of width n is divided into n equal parts. I told you every point on this acts like a source. N equal parts with amplitude small a and the adjacent phase difference. So if you are dividing them into n lines passing like this, whose amplitude is a and whose path difference, we need adjacent path difference. So we have total path difference. So the phase difference between any two consecutive waves from these parts would be given by 1 by n into total phase. So 1 by n into total phase will give us the phase difference between any two consecutive waves. So 1 by n, and what is the total phase difference we have? 2 pi by lambda into E sin theta. Let us assume this is equivalent to D. Let us say this is equivalent to D. Right? Now, using method of vector addition, of amplitude A and phase difference, let us try to find out phase difference D. Let us try to find out the resultant amplitude, and we know the resultant amplitude is equivalent to A sin nd by 2 by sin d by 2. So this is the resultant amplitude of n vectors whose amplitude is A and whose adjacent phase difference is D. So already we have the D value with us. So in this resultant amplitude expression, let us keep that D value. So what happens? A sin n by 2 into what is the D value in this case? D value is equal to 1 by n, or let me write this as 2 pi by n lambda into E sin theta, right? By sin 1 by 2 into sin 1 by 2 into again D value. What is the D value? 2 pi by n lambda into E sin theta. So in this case, what is happening is this n 2 will be cancelled in the numerator, and coming to the denominator is 2 and 2 will be get cancelled. So the resultant amplitude R is equivalent to A sin, what are the left out things after cancellation? Pi by lambda into E sin theta by sin pi by n lambda into E sin theta. where let us assume where we want to write alpha is equivalent to pi by lambda into e sin theta. That means wherever we are going to find pi by lambda into e sin theta, that we will replace with the alpha. So what happens is r is equal to a sin alpha by sin alpha by n, right? So as alpha by n value is very small, we will ignore sign in the denominator, so it will convert into r is equal to a sin alpha by n. So n a into sin alpha by alpha. Since n number of waves into the small amplitude A will represent as the resultant amplitude capital A, so R is equal to A sin alpha by alpha. So at point P dash, what we are going to get depends on this resultant amplitude. As we know, intensity is equivalent to square of the amplitude. So the expression becomes a square into sin alpha by alpha whole square. So this is the expression for intensity due to single slit. Now what will happen to this intensity? That means when it will become maxima, when will it become minima, and when it is going to have secondary maximas, we will discuss under the heading intensity distribution. Intensity distribution. Right, first of all, let us try to think of the condition when I will become equivalent to a square. So when I becomes equivalent to a square, we will call it as this central maximum condition. Here we are going to get I is equal to a square. So when we are going to get minima and when this p dash will become the secondary maxima, those things we would like to see now. So first of all, our task is to make I is equal to a square. So to become I is equal to a square, what should the condition here? Sin alpha by alpha should become equivalent to 1. So this condition will try to call as central maxima. So condition for central maxima or principal maxima or primary maxima. So I should become equivalent to a square, that what we are looking for, and that is possible only when this sin alpha by alpha is equal to 1. So when we are going to get sin alpha by alpha, according to L'Hospital's rule, limit alpha tends to 0, sin alpha by alpha is equivalent to 1. So in that case, this 1 square is nothing but 1 into a square, so we are going to get I is equal to a square when limit alpha tends to 0, sin alpha is equal to 1, right? So alpha tends to 0, that means alpha should become equivalent to 0. So what is alpha? We have adapted as alpha is equal to pi by lambda into e sin theta. So pi by lambda into e sin theta must be equivalent to 0, or else e sin theta is equal to 0. And when we are going to get theta is equal to 0 along, so theta is equal to 0 degrees, we are going to achieve this condition. So when theta is equal to 0 degrees, we will call it as central maxima. your total intensity will become equivalent to A square, right? Now let's go for the second condition when it is going to become minima. So minimum intensity positions, minimum intensity positions. Where do we get this minimum intensity positions? So when we will get minimum intensity, so when I is going to become 0, we will say this is minimum intensity. So that means I should become 0. So when this I is going to become 0, the condition for I is equal to become 0 is sin alpha should become 0. Sin alpha should become 0. So when alpha is equal to become 0, alpha is equal to plus or minus pi, plus or minus 2 pi, plus or minus 3 pi, etc. Or simply plus or minus m pi. M is an integer which is going to take the values of 1, 2, 3. So alpha should become plus or minus m pi. What is the value of alpha? Pi by lambda into e sin theta. Pi by lambda into e sin theta should be equivalent to m. So pi cancel. So e sin theta is equal to m lambda. E sin theta is equal to m lambda is the minima condition, or alpha should be equivalent to plus or minus m pi. That is the condition when we are going to get the minimum density. And another important thing what we are going to get in interference, not in interference but in diffraction, is in interference the intensities are going to become I is equal to 4a square maxima, intensity maxima, and I is equal to become 0 is the intensity minima. Only two cases arises in the case of interference. But coming to this diffraction, I is equal to a square is the maxima condition, I is equal to 0 is the minima condition. Apart from the central maxima, we will have secondary maximas also. Secondary maxima, right? To get this secondary maxima, in addition to principal maxima, we have two secondary maximas, and these secondary maximas are weak compared to the second primary maxima, and these again going to stay equally spaced between minima. These positions can be obtained with the rule of finding maxima and minima of a given function in calculus. So what we are going to do is we are going to differentiate di by d alpha, and we are going to equate it to 0, right? Di by d alpha is going to be equivalent to 0. So d by d alpha of a square sine so d by d alpha, what is the intensity? A square sine alpha by alpha whole square should be equivalent to 0. So differentiating the above expression, so what we are going to get is a square 2 sine alpha by alpha into alpha cos alpha minus sin alpha by alpha square is equal to 0. But already sin alpha is equal to 0 is the condition for minimum intensity. So we should not make use of again sin alpha is equal to 0. Now what is the other thing we can make equal into 0? So in this expression the other thing what we can make 0 is this alpha cos alpha minus sin alpha. So alpha cos alpha minus sin alpha is equal to 0. It means alpha cos alpha is equal to sin alpha. So alpha is equal to sin alpha by cos alpha. So alpha is equal to tan alpha. So by making use of finding minima and maxima of two functions, so we will draw graphs for y is equal to alpha and y is equal to tan alpha. So what happens now? So let us draw the curves. So this is our x-axis, this is our y-axis. Okay, so 0, pi by 2, pi, 3 pi by 2, 2 pi, 5 pi by 2, and the other side also minus pi by 2, minus pi, minus 3 pi by 2, minus 2 pi, minus 5 pi by 2. So what is the nature of y is equal to alpha? So y is equal to alpha is a straight line passing through the RG. Okay, it is the line passing through the RG. Right? So let us redraw this neatly. So y is equal to alpha is a straight line passing through the. And coming to the other one, what is the other one? Y is equal to tan alpha. So tan alpha value is 0 at 0, and this is going to approach, and this is going to approach infinite at pi by 2. Similarly, minus pi by 2. Again at pi, it is going to 0. At minus 3 pi by 2, it is going to approach infinity. Again at 2 pi, it is equal to 0, and at 3 pi by 2, it is going to become 0. So the same thing you can adapt the other side also. So now what are the intercepting points of y is equal to alpha and y is equal to tan alpha? So the intercepting points are at alpha is equal to 0, one intercepting point, alpha is equal to 3 pi by 2 is the second intercepting point, alpha is equal to minus 5 by 2, so plus or minus 5 by 2, plus or minus 3 by 2, and these are the intercepting points of the curve y is equal to alpha and y is equal to tan alpha. But already alpha is equal to 0 condition is our central maxima condition. So we are looking for secondary maximas, and secondary maximas we will get only when alpha is equal to plus or minus 3 pi by 2 and alpha is equal to plus or minus 5 pi by 2. So if we substitute these alphas in I is equal to a square sine, what is alpha first? 3 pi by 2 by 3 pi by 2 whole square. So it is going to become equivalent to a square by 22. Similarly, I is equal to a square sine 5 pi by 2 by 5 pi by 2 whole square, nothing but a square by 62. So in the case of diffraction, we are getting I is equal to a square as central maxima, and I is equal to a square by 22 as the first order maxima, and I is equal to a square by 62 as second order maxima. So we can understand that as the artery is increasing, the intensity is going to decrease. So finally, let us represent the intensity curve of the diffraction due to single slit. This is our x-axis. So this is our y-axis. So alpha is equal to 0, pi, 2 pi, 3 pi. Similarly, we said minus pi, minus 2 pi, minus 3 pi. So if we draw the curve, so at alpha is equal to 0, what is the intensity? A square. A square, okay? And it is going to become minima. What is the minima condition? Plus or minus n pi. And between pi and 2 pi we have 3 pi by 2. So at 3 pi by 2, what is happening is again it is becoming secondary maxima. I is equal to a square by 22. Here I is equal to a square, and again it is becoming minima, and between this 2 pi and 3 pi we have 5 pi by 2. There intensity is equal to a square by 60. So similarly, so 0, and here we are going to get at 3 pi by 2. Again I is equal to a square by 22, and I is equal to a square by 60. So like that, minima at whenever sin alpha is equal to 0, that means alpha is equal to plus or minus m pi, we are getting minimas. Alpha is equal, and alpha is equal to 0, theta is equal to 0 directions, I is equal to a square, and at 3 pi by 2 and 5 by 2, we are going to get the secondary maximas.